So this video is going to focus on taking a look at some data in graph format and then being able to read and interpret what this graph is trying to tell you as a scientist. So there's a couple questions that I want you guys to think about. You know, whether it's I give you a graph or you're doing an experiment and you're making your own graph, I want you to just stop and ask yourself a couple questions. Okay, first question is, what is this graph trying to tell me? Now that might be kind of tricky, so you can ask yourself this question. What do I see in the graph? Based on what you see, you should be able to then pick out what the graph is trying to tell you. First place to look, I always say, is right up here at the title. Okay, so if we look at the title, it says we have temperature versus CO2 over time. Alright, so I've got temperature, which might be a variable. I've got CO2, which is a variable, and then I also have time. Those three things should be in my graph. So if I look, temperature, do I see that anymore? Oh yeah, temperature is in red. Carbon dioxide, is that anywhere? Yep, that's in blue. Alright. Time though, time's kind of tricky. It's not actually in the data. It's actually up here. Alright. Okay, good. So we got the title done. Well, now let's look at the axes. On the y-axis, I've got temperature, one of my variables. That goes over here. And then I've got carbon dioxide. Deals with these numbers over on the right-hand side. And then time is going to be up here. So this is time. All right, now let's take a look at the units. Temperature is in degrees Fahrenheit. Now, it doesn't always have to be in degrees Fahrenheit. It could be in Celsius. It could be in Kelvin. What you need to do, though, is, we're used to degrees Fahrenheit. So if this was in Celsius or something like that, you have to kind of change the way you think to kind of understand these temperatures. Right now, negative 60 degrees to negative 84 degrees Fahrenheit, that makes sense to us. That's really cold, okay, especially or even compared to what we have here in Minnesota. Now, carbon dioxide, that is in parts per million. Now, that one might be tricky. You might have to do a little bit of background research to figure out what parts per million actually means. All right. Good. Time is in years. However, if we look at our x-axis up here, this is 0 years ago or before right now. Okay, so that's this line. Usually we think maybe time starts at 0 on the left-hand side and then increases to the right. This one's backwards. Okay, and that's okay. We just have to remember that that's what this scale is for the x-axis. Well, now let's take a look at the scale for the y-axis. Over here, carbon dioxide in parts per million, we start out with a low number, 180, and we increase to a big number, 330. Okay, that's normal for us. Down here, we start with a big number and with a small number. However, because it's in temperature and it's negative degrees, we're still increasing temperature as we go up, right? Negative 60 is warmer than negative 84 degrees, okay? All right. So now we have a better understanding of the axes and that kind of stuff. Now we can actually take a look at the data itself. Okay, here we go. Here we go. So, what do we see? Again, stop, take some time, look at the actual data, and what do we see? Questions to ask yourself are, where are the highs and lows? Highs, lows. Where are they? Do we see any patterns? That's another important one. Are there any patterns? Is there any data that doesn't match? Okay, all important questions. All things you can actually go and look for. Okay. So if we look, where are the highs and lows? Let's see. If we look at the blue data, our blue data is for CO2 concentration. Our highest is right here, so I'll put a little star right there. And our lowest blue data kind of looks like it's right here, so that's our lowest blue data. Then we can also go look for our highest red data, our temperature data. Looks like our highest temperature is over here, and our lowest temperature kind of looks like it's right there. Good. Okay, so highs and lows for both sets of data. We got that. Any patterns? What do you see in the data? Okay, and I think one thing that you should notice is that the lines follow each other. Whether it's the red line or the blue line, as one increases, the other one increases at the same time. Whereas one decreases, the other one decreases as well. Okay, when that happens, okay, when both sets of data follow each other, okay, we call that a direct relationship. There is a direct relationship there. Okay, so we would say that there's a direct relationship or direct correlation between temperature and CO2 concentration over time. Okay, now we're not going to focus really on time here because we're not really measuring the time. Time is not going to change. All right, it's going to stay at the same speed. It's not going to speed up or slow down. What we're really focusing on here in this data is the temperature and the CO2 concentrations. Okay, so we're only looking at that data, and we see that there's a direct correlation, direct relationship between temperature and CO2. Is there any data that doesn't match or go with the pattern? I guess I would say no, there isn't really any data. But maybe if there was some like funky CO2 concentrations here, okay, this stuff wouldn't match the rest of the data. You could call that an outlier. All right. Let's take a look at another set of data. Okay, this would be volume versus pressure. Okay, same deal. Stop. Take a look at the graph. What are you trying to figure out? Okay, what is this data trying to tell me? We've got the title, volume versus pressure. Okay, so I should see those two things in the data somehow. Volume is on the y-axis. Pressure is on the x-axis. All right. Again, take a look at your units. We've got liters over here, something called kilopascals down on the x-axis. How do the scales work? We're going to increase going up, and we're going to increase this time going to the right. So I've got both zeros over here in the corner. All right. So now, what does the data actually tell me? Okay. What I see is this decrease in the line, right? We go from low pressure, high volume, all the way over here to high pressure, low volume, right? So what kind of relationship is that? So let's say as we increase the pressure, as pressure goes up, what happens to the volume? Does it also increase? So as we go this way, what happens to our red dots? They actually decrease. All right. So as pressure increases, volume decreases. This is called an inverse relationship. Inverse relationship. And that's important to remember. Okay, so these two things don't really match. They're going in opposite directions. Okay, I could say the same thing as volume increases, pressure decreases, right? They're still going in opposite directions.